Okay, we're going to start section 5.2 today. This chapter is focusing on polynomials. What we're going to be looking at in this section is how to divide two polynomials. We've looked at how to add, subtract, and multiply them. Dividing is probably, or can be, the most difficult of all of the operations to perform on polynomials, but we're going to start with the easiest type of division problem, and that's when you are taking a polynomial and you're just going to divide it by a monomial. This prefix mono means one, and so you can see that in this first example we are dividing a trinomial by a monomial, one term. Okay. Now what you're going to do for these problems, I think the easiest way to do this is you're going to take each of the terms that you have in your numerator and you're going to write those out separately as if each of those terms become the numerator of their own personal fraction. And then you're going to take the denominator, in this case the 3xy, and you're going to put a 3xy underneath each of those terms in the numerator, kind of creating three individual fractions. And you'll notice that there was a subtraction sign here, so I carried that down as subtraction in front of that fraction. Okay, once you have this split into three individual or separate fractions, then you can kind of treat each fraction separately, if you will, and sort of reduce the numbers and then cancel any variables that you could cancel. So for example, 6 divided by 3, we would say that's 2. If we have x to the 4th in the top and only one x in the bottom and we canceled, that would leave us with x cubed in the top. Same thing with the y's, we would be left with y squared. Okay, if we do that same thing moving across here, 12 divided by 3 would be 4. We would be left with x squared y, and then the last fraction would be 6x, and you notice that these y's right here completely cancel each other out, and so there is no y here. Okay, and that is what we would then say would be the result of dividing this trinomial by this monomial. And you can see that I did this second example here for you. I do want to just draw your attention to the fact, though, that the third fraction, you'll notice that the numerator and denominator were identical, so the 4's, C's, D's, and F's all canceled. Okay, when everything cancels, we leave a 1 as a placeholder. Okay, you learned that probably in elementary school, that when you have a fraction and the numerator and denominator are equal, that always reduces to a 1. Okay, so there are going to be a few problems. You'll notice on the homework assignment, this assignment is out of the book. However, there are 3 additional problems in this box here that I also want you to add to the book assignment, and these 3 problems are just like what we did here. It's dividing a polynomial by just a monomial, and you will just use this process here of kind of splitting it into the separate fractions. Where we're going to spend most of our time here today, though, is we're going to be looking at long division, and this would be a case where we're going to be dividing a polynomial by maybe a binomial where we have 2 terms that we're dividing by. And before we jump into that example, I just want to take you back to when you very first learned about long division, of just long division of constant numbers. I want to talk through what you do if you didn't have a calculator and you were going to perform this longhand, what your process is, because if we can review that process, I think that you're going to see a lot of parallels that happen when we are dividing by 2 polynomials as opposed to 2 constants. So we know that when things are written as a fraction, that's really just division. And so when we see this 503 over 12, we know that means that 503 is being divided by 12. And this would have been like the old school way that you would have learned how to do a long division problem here. Okay, keep in mind your numerator is what goes underneath the division bar, and the 12 is what comes out in front. That's what you're dividing by. Okay, now the way that we would have done this then in elementary school is because we are dividing by a number that has 2 digits to it, we would want to look at the first 2 digits of our number under here, and we would be asking ourselves, how many times does 12 fit into the number 50 without going over? Okay, so if you think about that, 12 will fit into 50 4 times. Okay, it'll go in there 4 times. And so then what we would do I just want you to think through this process, like what the next step would be, because I think sometimes we take this for granted, and I want you to really think about what you're doing to get that next step, because that's kind of what the process is for when we're dividing polynomials together. So what you do next is you multiply that 4 by the 12. Okay, so we're going to multiply the 4 by the 12, and we write that answer directly under the 50. We get 48. Okay. And then if you think about what you do next, you don't ever add 50 and 48, even though when I have the 48 written here, it's positive. What we end up doing is we end up flipping the sign on the 48, making it negative, and then we subtract 48 from 50, giving us a 2. Okay? Well, 12 does not fit into 2, and so then the next step is we drop down the next digit to go along with the 2, and so now we're looking at 23, and we're asking ourselves the same question: what would we, or how many times would 12 fit into 23 without going over? Okay, and the answer is it would only go in there once. Okay, so then we take that 1 that we just put up top, and we multiply the 1 times the 12, and we write that answer underneath the 23. Okay. Again, I'm not adding 12 and 23. I'm going to flip the sign on the 23, and then I'm going to subtract 12 from 23, and that would give me 11. Okay. Once we've dropped down everything that there is to drop down here, if we're left with anything extra, that is what our remainder is. And so when you write the remainder, we often write this as a fraction. 11 is the remainder, and we divide that by the number that's out in front here, the 12. Okay, that's called the divisor. Okay, so the answer is that 12 goes into 503, 41 full times, and then also 11 12. So almost one other full time, but not quite. Okay, we are going to, I went through that slowly because again, I think you're going to see a lot of parallels when we look at that with this example here. So let's go ahead and set this example in a very similar way here. There's different ways that you can be shown that it's a division problem. It could either be a fraction, or it could use this division symbol with the 2 dots, but it's the trinomial that's being divided by the binomial. So you want to make sure when you set this up that the trinomial is going underneath the division bar and the x minus 1 is going out in front. Okay. All right, so what you're going to do is, remember here, we compared the 12 to the first couple digits of the 50, and we asked, how many times would 12 go into 50 without going over? You are going to only ever compare the first term and what's out in front, and this is assuming that you've got things in descending order, by the way. You're going to compare that first term with the first term that is underneath the division bar. And the question you're asking yourself is, what could you multiply x by to get it to look like an x squared? Okay, like we were trying to get 12 to look like a 50, but we couldn't quite get it there, so we had to get as close to 50 as we could. But in this case, there is something I could multiply x by that would make it look like this first term, x squared, and the answer is multiplying it by another x. So I'm going to put an x up top, okay, and then what I'm going to do, again, think about what we did with this 4. Once we had the 4, we multiplied the 4 times what we had out in front to get the 48. So I have 2 things out in front here. I have an x and I have a minus 1. So I'm going to distribute the x to the x, that gives me x squared, and then the x to the negative 1, that gives me minus x, okay? All right, so I'm just going to erase this so that we don't have that there for the next step here. Now recall, once we put the 48 here, remember what we did with it. We flipped the sign on the 48. So if it was positive, then we went ahead and made it negative. Well, everything I have here in orange, I need to flip the sign on all of that. If it's positive, I want to make it negative, and if it's negative, I want to make it positive. Okay, so I'm going to make this negative, and I'm going to flip the sign on this and make that positive. Okay, then I'm going to go ahead and add down. When I add down, this first column should always cancel itself out. So x squared minus x squared, that's gone. Okay, now I'm taking negative 13x and I'm going to add an x to it. So that would be negative 12x, and then recall we drop down the next digit up here to go next to our 2. So what we would do next is we would drop down the next term, 12, to go next to our negative 12x. Okay, then we're going to repeat the process again. Okay, every time you're repeating the process, you're always comparing the first term in your divisor to the very first term in what you've got over here on the right. And what you're asking yourself is, what could we multiply x by to get it to look like a negative 12x? Okay, well, we could multiply it by a negative 12. Okay, so we're going to multiply it by a negative 12, and then we're going to distribute that negative 12 to the x and to the negative 1. Okay, that would make this negative 12x. That would make this positive 12. Okay, now it's the next step that most people forget. Once you've distributed and you've written that down, the next step is you have to change the signs on what you just wrote down. So if it's negative, we make it positive. If it's positive, we make it negative. Okay, I'm going to draw my line. This first column should always cancel. It just so happens that in this problem, the second column canceled. I have nothing more to drop down. So if I'm left with a 0 there, that means that I'm not going to have a remainder at all for this problem. So my answer to this problem is simply x minus 12. Okay? If you recall the way that division works, I'm just going to use something really simple here. If we take 6 divided by 3 and we put a 2 here and we get no remainder, what that basically means is your answer, when multiplied times your divisor, these two things multiplied together should give you what you originally had under the division bar. So if I use that same logic, then this is saying my answer of x minus 12, when multiplied by my divisor of x minus 1, if I were to FOIL these out, x squared looks like minus x minus 12x plus 12, it looks like what I end up getting is, look, I end up getting that same original thing that I had underneath the division bar, okay? All right, so let's go ahead and try example B, because there is a little nuance in example B here that I want to look at with you. Okay, you'll notice in this problem here, when we were dividing by 503, you'll notice that we put a 0 in the tens place, and the purpose of that 0 is a placeholder. Okay, when you don't actually have anything in that place, in this case the tens place, we always put a 0 there just to hold the value of that place. Okay, I mention that because when we set this problem up, you'll notice that it's the 9x squared minus 5 that's being divided by the 3x minus 1. But if you look at this 9x squared minus 5, you'll notice how it jumps from the x squared term all the way down to the constant. It's skipping the x to the first term. Okay, so we're going to need to put in a placeholder to hold the place of the x to the first term, even though there are no x to the first. Notice that I've just put a 0 in front of it so that it's going to hold the place of that. And you'll see why that's valuable when we get through this problem, but we need to hold that place so that everything's going to stay lined up. Okay. All right, so we're going to go through this one a little bit faster, but you're going to compare your first term in front with the very first term underneath. Again, the question that you are asking yourself is, what could you multiply 3x by to get it to look like a 9x squared? And the answer is 3x. Okay. So you take that 3x, you distribute that 3x to the 3x, and then also to the negative 1. Okay, then we circle back, we flip the signs. Okay, we're going to flip the signs here. I always expect the first column to cancel, and now you can really see the value of the placeholder. Had I not put this placeholder in, this negative 5 would have been right here in this spot, and I can't combine a constant with something that is x to the first. You'll notice all your columns are always lined up as like terms. And so in this case, when I add down, I'm taking 0x plus 3x. Well, I'm still going to have just a positive 3x when I add these together. Okay. Okay, and then we drop down the next term. Okay, just so we don't get confused, I'm going to erase those orange arcs there. And then we are repeating the same process, only this time comparing the 3x out in front with the 3x underneath. And what would we multiply 3x by to get it to look like a 3x? The answer is just a 1. Okay, so I distribute the 1 to the 2 terms out in front. I get 3x minus 1. I'm going to flip the signs. This becomes a negative. That becomes a positive. I'm going to add down. Now in this one, when I add these down, I get a negative 4. So on this one, I am getting a remainder. Okay, remember what we did with our remainder of 11 right here. We wrote it as a fraction. The remainder actually goes in the numerator. The denominator is your divisor, what you're dividing by. So in this case, I'm just going to put a subtraction sign there since my 4 is negative. So this represents my negative 4. Okay, that's in my numerator. And then I'm going to divide by the divisor, which is the 3x minus 1. That goes in the denominator. Okay, and that would be my answer to this particular problem. Okay, I just want to look at 2 more with you here. Okay, let's take a look. One thing that I want to look at before we're going to end with example 3, but before we do that, I just want to make a small alteration to the problem, to a problem here. We're not going to do this entire problem, but you've noticed all the ones that we've done when we've posed the question, what would 3x get multiplied by to be a 9x squared, that it was always an easy answer. Okay, you might not always have an easy answer for this. For example, in this one here, you're going to be comparing a 3x to not a 9x squared, but this would be a 10x squared. And so the question is, well, what are you going to multiply 3x by to get it to be a 9x squared? Well, I know I need another x, but I need to figure out, I'm really needing to figure out what number should I be multiplying 3 by so that it's going to come out to be the number 10. And when you pose that question to yourself, you can always write it in the form of an equation, just like I did here. 3 times question mark, what number times 3 would come out to be exactly 10? And then you have good enough algebra skills here that you should be able to solve this equation for that question mark. I'm going to divide both sides by 3, and I've got my answer, that 3 times 10/3 is what would make it 10. And think about that. If I took the number 3 and I multiplied it by a 10/3, these 3's cancel and I get a 10. So that means up here I'd be putting 10/3 x as my first term. Okay, and then I would go through and I would multiply 10/3 x times 3x. That would give me a 10x squared, and then 10/3 x times negative 1. And then I would just kind of continue on with the problem, flipping the signs. Here, I would probably use my calculator to add 4 and 10/3, but do make sure that you always write your answer as a fraction. So I would encourage you to use that math fraction button to always make it look like a fraction. Okay. All right, so let's try one more here. This one is kind of a big problem. The reason it's so big is because there are a lot of placeholders that need to be put in place here. So I'm going to make this division bar really large here. My 3z minus 6 goes out in front, and you'll notice it starts with z to the 6th, but it skips z to the 5th. So when I'm organizing this here, I'm going to need a placeholder for z to the 5th. You'll also notice that it skips z cubed and z squared. So I'm putting placeholders in 0 z cubed, 0 z squared. And actually, if it doesn't show you a constant, you also need to put a placeholder in for that. So this one required 4 placeholders that I had to actually put in. And that's why this problem feels like it's so long here. Okay, all right, let's see if we can go ahead and go through this here. We're going to compare those first terms. What are we multiplying 3z by to get 6z to the 6th? The answer is 2z to the 5th. Okay, we're going to distribute 2z to the 5th there to both of those terms. Okay, if you recall, the next step is to flip the signs, add down, first column is gone. 0z to the 5th plus 12z to the 5th is still 12z to the 5th. Drop down the next term, and we're going to repeat this cycle again. Okay, several cycles through this one here. Okay, now we're asking ourselves, what are we multiplying 3z by to get 12z to the 5th? The answer would be a 4z to the 4th. We're going to distribute a 4z to the fourth to both of those terms out in front. We get 12z to the fifth minus 24z to the fourth. I'm going to flip this to a negative, that to a positive, add down. Okay, now be really careful here. This is 3z to the fourth plus 24z to the fourth. That gives me a total of 27z to the fourth. I'm going to drop down the next term. Okay, all right, so now we're going to compare that 3z out in front to the 27z to the fourth. What are we multiplying 3z by to get 27z to the fourth? Looks like that would get multiplied by a 9z cubed. Okay, then we continue with distributing a 9z cubed. That's going to be 27z to the fourth minus 54z cubed, flipping the signs, adding down. Okay, so here's the problem with long division, especially long problems like this one with long division. If you make a mistake early on, everything from that point after is going to be messed up, because you can see how the problems are building and they're snaking around and they're spiraling, and you're using that answer to dictate what the next term is in your answer. So that's why you don't want to rush through these, because everything after you've made a mistake is incorrect here. Okay, so we're saying 3z times what gives you 54. If you're not sure, on your calculator you could divide 54 by 3. It would go in there 18 times. We do need a z squared here, so I'm going to distribute an 18z squared to both of those terms. That's going to give me 54z cubed plus 108z squared. Again, with the flipping of the signs, we're going to add down, cancel that first term here. So I've got, let's see, I think I may have made a mistake here. I'm thinking that originally this was subtraction, and when I flipped the sign, it made that positive. Okay, so this is going to carry down to 108z squared. I'm going to drop down. We're almost there. 2 more cycles through this here. Okay, so now we want to know, what are we going to multiply 3 by to get 108? We could, on our calculator, divide 108 by 3. That gives us 36. Okay, so we're going to put plus 36 and a z up top here. Okay, again, distribute the 36z to both terms out in front. Gives us 108z squared minus 216z. Flip, flip, add down. These numbers keep growing and growing. Got to be careful when you combine these. This is negative 9 plus 216. That's a 207z. Last one, we're going to drop down this 0 and do this one last time here. Okay, so I am comparing 3z to 207. So if we took 207, divide by 3, I believe that goes in there exactly 69 times. So we're just 69. Now no z here, okay, because the z's match up already. Okay, we're going to distribute that 69 to both of those terms. That's going to be a 207z, I think minus a 414. Okay, one last flipping of the signs. And it looks like we are left with a remainder of 414. So I'm going to add the fraction 414 over what I was dividing by, 3z minus 6. Okay, all of these problems that we're doing today are all long division problems, with the exception, don't forget about these 3 here. They are just like